Hey everybody. So direct follow-up to the previous video where we were trying to figure out which way the blocks were going to slide, and here I just plugged in the numbers, and then right here, so that's going to be 4 times half, so that's 2, and then sine 60 is root 3 over 2, so like root 3 over 2 times 2 is root 3, and this was 2, and root 3 is definitely less than 2 because root 4 is 2. So that means this number is positive, and that's positive, and that's positive. So that means the entire thing is positive. Yes, right? So that means I happen to pick my axes in the positive direction. It was just 50-50 chance. So that means now we know they're definitely going to slide this way and this way. So how about a follow-up question? Let's say we know the kinetic friction between this block and this ramp and this block and this ramp. Like it's 0.1 or something. Like we know the number. Solve for the acceleration of the blocks as they slide. So let's give this a try. So, right, we start with the free body diagrams. There's for this block, and then the other block. So I'll call this block 1. Let's just call this M1 and M2. So there's the rope, normal force, weight. And then now that we know block 1 is sliding up the ramp on the left side, I know to draw the friction opposing the motion here. Kinetic friction. Oh, just for block 1. And then for block 2, it has weight, normal force, tension in the rope. And now that I know it's sliding this way down the ramp, I know to draw the friction this way opposing the motion. Kinetic friction for block 2. Okay, so now we have both free body diagrams. We wouldn't have been able to draw the direction of the friction if we didn't do this step first, right? So it kind of makes it complicated. All right, let's pick coordinates. So my personal preference, now that I know which way they're sliding, I'm gonna pick my coordinate this way in the direction that it's moving, this way. Okay. You don't have to pick your coordinates the same way I pick. And then I look at this angle, and then I know that's over here. I look at this angle, know that's over here. Okay, so now let's write Newton's second law based on our 2 free body diagrams. So in the x direction, I got this, this, and this. So t is in the positive direction, the weight negative, and is opposite. And then friction, mass times acceleration. Y direction, we go this and this. Mass times acceleration. I know that it's sliding in the x direction and no motion in the y direction, so immediately I can cross this out. Okay, next this one. X direction, I picked x over here. So I got this and so 3 of those things. So that's opposite the angle, minus t, minus friction. This is for 1, and this is for 2. Mass times acceleration. Y direction, I got that and that. equals mass times acceleration. Similarly, this is only moving in x, no motion in y, so I can cross this out immediately. Okay, and then we know one more relationship, that this friction is proportional to this normal force. That friction is proportional to normal force. This friction is proportional to this normal force. So I'll write that over here. Okay, and if we want to solve for acceleration, it's right here. But then there's a bunch of other unknowns, like we don't know this, we don't know this. We don't know the normal force. We don't know the normal force. Okay, it looks like 6 equations, 6 unknowns, but maybe it's not so bad, right? Take a look at what are the unknowns. Like immediately it stands out to me that we can solve for this. Right, so n1 equals m1g cosine theta 1. It's not so bad, right? Look at this one. N2 equals m2g cosine theta 2. And once you solve for n1, you can just put it right here, right? And then you know the friction. And then once you know the friction, you can put it right here. Okay, so let me write down what I'm saying. So here, n1 equals m1g cosine theta. So friction mu k n1, which is this. Same here, mu k n2, but n2 is m2g cosine theta 2. And then we can take this and put it here. Take this and put it here. So let me do that. So I'm going to write this equation right now. Minus okay, and then I'm going to write this equation. I'll just squeeze over here. Okay, so now that I rewrote those equations, I'll just say 1 and 2, these two. Right, there are 2 unknowns. So whichever way, maybe I'll solve equation 1 for t. I'll do that right now. Okay, and then I'll take this and put it right here. And then that way there's only one unknown left, which is ax. Okay, so I'm going to write equation 2. This one right here. Okay, so m2g sine theta 2 minus t, which is this whole thing. I'm going to write that right now. Okay, so we're right here, right? Minus this equals here. Okay, so if you look at it, it looks like a lot, but look, there's only one unknown. So I'll take this and move it on the side. And then all the rest of it just stays. I'm sure we can factor a few things, right? Like g, look, g is everywhere. Okay, so I can factor out g. And then I have m2. So I'm going to write this right now. m2 sine theta 2, and then this one is m1, and this one is m1, so it looks like I can factor out m1. Okay, and then that's, I'm going to write this one first. So that's, oh, this should, they're both negative, so I'm going to factor the minus sign out. There you go, minus. So let me write both of these right now. Sine theta 1, I'm writing this one. Mu k cosine theta 1. Okay, so I wrote this, this, this. And, oh, there's this, which also has m2, so I'm going to factor, might as well factor the m2. So here, so that's, there's a minus sign, minus mu k cosine theta 2. Okay. Equals, and then I'm going to move this on the other side. Okay, and then I can factor, I'm just going to factor it right now. m1 plus m2 ax. And then I can take this and move it in the denominator. So instead of me rewriting this whole thing, I'm just going to put this right here. There you go. So this is ax. Let me just move it over. There you go, this is ax. Okay, so give this problem a try, and then you should have the same answer as me, right? So let me know if you have questions. I'll see you on the next video.